Hello students, welcome back to my channel. In today's session, we will be learning the algorithm which helps us to understand how to raise a number to its largest power. So let us go ahead and see the problem statement. Given some integer x, compute the value of x to the power n where n is a positive integer considerably greater value. Okay, so basically what we are supposed to do is given any value x to the power n, we have to compute the product of that particular number. So basically we are trying to understand that what is the easiest or which is the simplest or which includes the less number of steps. So if you were to understand, the power or exponent of an integer is how many times a number is multiplied by itself. Now, what do you mean by that? So if I say x to the power 4, I can simply say that x into x into x into x. So if at all I have x to the power 4, it is nothing but how many times I'm going to multiply. So how many times I'm going to multiply the number of times I have my power. So that is what the power or exponent of an integer is. How many times a number is multiplied by itself gives me the exponent. So this is the 4 times, hence the exponent is 4. So with this basic idea, let us explore and understand how can we raise a number to its power. Okay, so the first method is naive iterative method, or a simple method where we simply multiply those many times. So this approach is to find the value of x to the power n by repeatedly multiplying x exactly n times and print the product. So product will be given by, if at all I have x to the power n, I'm going to multiply x n time and then I will generate a product. This is a naive iteration method. So in that case, if at all I had x to the power 20, I will do 20 multiplication. If at all I had x to the power 1000, I will multiply 1000 times and then there will be 1000 multiplication. So is there any different approach where I can reduce, because the if the exponent, then our power is more, those many times we have to do the multiplication. Hence, let us see if there is any other method or any other idea which we can explore, which will reduce this computation. Okay. So let us first understand the base case when n is equal to 0 and x is equals to 1. When n is positive and even, we know that when we multiply powers of x, we add the exponent. Now, this is the very basic idea. Okay, whenever we have x to the power a and x to the power b, and when we multiply that, this will produce x is equals to x to the power a plus b, which means to say, for example, if I have n square into n cube, this is nothing but n to the power 5. So we always add the powers whenever we have the same base. Okay, so for any base x and any exponent a and b, what can we conclude? If n is positive and even, then I can say that xn can be written as n by 2 and n by 2, which means when I'm going to add n by 2 plus n by 2, I'm going to get n. Similarly, if it is an odd number, then I can say that x to the power n is n minus 1 into x, that is, which is nothing but 1, which will give me n in case of an odd number. So what are we understanding with the help of this? So here basically we are trying to understand this concept where we add the powers of any given number with the same base, and let us try and understand, can we use this in order to compute the exponent value of a n? Okay, so before directly coming to the algorithm, let us discuss some other examples. So let me give an example where the power is even. Okay, so suppose I'm saying a to the power, let me just take 13 itself. Okay, or let us take a different value here. I will say a to the power 6. Now we know that a to the power 6, according to this, I can say that it is a to the power 3 into a to the power 3. All right. Now, how can I write a to the power 3? According to this, I can say that a to the power 3 can be written as a to the power 2 into a. Okay. And then, which is once again multiplied with a to the power 2 into a. So, which means to say, Instead of multiplying it so many times, all I need to do is take a value of a, take a value of a square, and then calculate the value of a cube. I can land at the value of a to the power 6. So if I know the value of a square, which is nothing but a into a, I will get the value of a square. Now to calculate a cube, I already have the value of a square. All I need to do is a square into a. Next, to calculate the a to the power 6, all I need to do is a cube into a cube. So how many multiplication I'm doing here? 1, 2, and 3 multiplication. So instead of saying a to the power 6 is equals to a into a into a into a into 6 times, okay, instead of doing 6 multiplication, I can complete my work with only 3 multiplication. Okay, that is what the idea here is. We are trying to understand. Let us take an odd number, a to the power 13. I want to calculate the power of a to the power 13. So usually we will take using the old method or a simple method. I can just multiply it 13 times and I will get the value. Let me just find out a different way. Let us use this method where a to the power n. In case of odd, I can write it as x to the power n minus 1 x, which is nothing but x to the power 12 into, sorry, this is not plus, this is multiplication into a. So this will give me a to the power 13, of course. Now, how can I write a to the power 12? Now, 12 is an odd number which can be easily written as a to the power 6 into a to the power 6. Now, how can I get the value of a to the power 6? It is nothing but a to the power 3 into a to the power 3. Next, how can I get the value of a to the power 3, which is nothing but a square into a. And how do you get the value of a square, which is nothing but a into a. Okay, so how many steps do I have here? 1, 2, 3, 4, 5. Just with 5 multiplication, I can compute the value of a to the power 13, unlike 13 times multiplying. So this is a very effective way in order to raise a number to its power. All right, so now let us go ahead and see the algorithm. So initially, we will start with declaring the variables x, n, and the product. Initialize product is equals to 1. Read x, n, n. Suppose I am reading the value of x is equals to 3 and value of n is equals to 9, which means to say it is 3 to the power 9 is what I want to calculate. All right. Now, read x and n. While n is, this is the first repetition, while my n value is 9 is greater than or equal to 0 if n is odd. Now, how do you find out n is odd? Of course, you will use the mod 2 operation, which is already being discussed in the previous sessions. So kindly go through those. So if it is completely divisible by 2 and remainder is 0, we will consider it as even. If not, it is odd. Okay, if n is odd, in this case 9 is not going to be divisible by 2, hence it is odd. We know that it is odd. Multiply the result by x. So what we are going to do, the moment it is an odd, remember whenever we have a to the power 3, we will say that a square into a. So this is what we are doing. We are multiplying the single value to the product and keeping it. So product is equals to product, that is 1 into x value is 3, which I'm going to get it as product is 3, and then divide n by 2. So why do I need to divide n by 2? Because I want this value. So I will say n is equals to n by 2. So when I say 9 by 2, of course we are going to get 4 by 5. Now it is an integer value, hence we are going to take only the integer value. Hence n is going to get the value 4. Okay. Now divide n by 2, and then we will also keep x is equals to x into x, which is nothing but 3 into 3, which is nothing but 9, because we need to do this value. Okay, now x has a value 9. Second iteration, we will go back and check what is the n value. Is the n value greater than 0? Of course, the n value is 4 now, which is greater than 0. Okay, and then if n is odd, multiply the result by x. So in our case, it is not odd, hence we are not going to multiply. Okay, so what has happened here? Initially, we had 3 to the power 9. Now we did it as 3 to the power 8 into 3. So this is already done. Now we are working on this. So this has been divided into 3 to the power 4 into 3 to the power 4. So now we are trying to calculate this. Okay. So if n is odd, multiply result by x, but it is not. Okay, so we are not going to find out the product, but I'm going to divide n by 2. So what is going to happen? N is going to get the value 2. Why? Again, because we want to further find out this value. Okay, and n is going to get the value 2, and then I'm going to find out the product. So x is going to get the value 9 into 9, which is nothing but 81. 81 which we are going to get, which is I'm trying to calculate this. Next, once again, third iteration, I'm going to check if n is 2 is greater than 0. Of course, it is greater than 0. And I will check if it is odd. It is not odd. Hence, I will directly divide the value of n by 2. When I divide by the value of n by 2, I'm going to get n value as 1, which is nothing but I'm trying to find out this one, 3 to the power 1 and 3 to the power 1. Okay, so when I get n value is 1, and then I will directly multiply, which is this calculation we are doing. I'm saying, sorry, not this calculation, we are trying to calculate this. So I'm going to say x is equals to 81 into 81, which will give me the value 6561. All right, now once again, n value is 1. I'll come back to the loop. I will check is n greater than 0. Of course, it is greater than 0. And then we will check if n is odd. Yes, n is odd. Hence, what I'm going to do. So this calculation, when n is odd, I'm going to say product is equal to, which product already had the value 3. I'm going to say that 3 into the value 3 into x. Now what x has? X has 6561. Hence, I will get the value 19683. So what we are doing is we're retracing back. All right. So this is the value what we are going to get. So with 3, I have now multiplied the value of 3 to the power 8, and hence I have got the value of 19683. Now, once again, what I'm going to do is n is equal to n by 2. So I'm trying to divide 1 by 2, which is, of course, I land up with 0. N value is now 0. When I come back to the while value, this is going to be failing, or this is going to be false. And hence, I will come out of this while loop to directly printing the product. Hence, my output is going to be 19683, which is nothing but 3 to the power 9. All right. And hence I will end the algorithm. So this is how raising a power to the largest number works. As you can see here, we have used only 4 steps, 4 multiplication, and then we are done with the finding the power. Otherwise, we had to multiply it 9 times, and we have reduced it so much so that it is giving us a perfect answer in less number of steps. So this is algorithm to raise the number to the largest power. So thank you for watching, students. Keep learning.